Okay, happy Monday, everybody. It is Monday, August 2nd. It is civic holiday if you're in Canada. So I kind of had today off. So I figured it might be a good time to do another tutorial. Got my usual evening and stuff cleaned up a little bit, so I have some time today to do a bit of a tutorial on Wrangling JSON. This is going to be this is kind of the third, I guess, in a series of me kind of running through stuff and going through kind of various R things that I'm very comfortable with, and things that I'm very comfortable with, and things that I want to kind of share with people, get recorded. Thank you for the raid, ODAT-Nerd. Welcome to the JSON party. We're about to go wrangle some stuff. Boom goes the raid dynamite. Yes, awesome. Okay, so I did some stream commands. So let me get those sorted out right now. Okay, so I've added 2 stream commands. Hopefully they're visible. The 2 stream commands special for today are wrangle this, which looks like this, and repo. No, not repo. What did I call that? Office hours? What did I call that thing? I thought I made one. Nope, we'll call it repo. HTTPS github.com tanho63 office hours. Okay, so I've got two stream commands that are special for today. They are repo and wrangle this. Thank you for the follow, S. Peterson. Okay, so today I want to talk about JSON. And I've got a few stream commands that should make it easier for you guys to kind of look at the stuff that I'm going to be looking at, and also give me stuff to look at. And basically the goal of these office hour streams, I don't prep content. It's not a tutorial in the sense that it's pre-recorded or pre-rehearsed. You're getting entirely informal, off the cuff me, and I'm just going to try to walk you through my train of thought as I tackle JSON, and what kind of I'll briefly mention what qualifies me to give a JSON tutorial. First of all, I'm not formally qualified or whatever, but I have a couple of packages on CRAN. That's CRAN. I don't know. Somebody memed it. Now I can't get it out of my head. But the idea here is that I have a package on CRAN that's specifically a web scraping package and a package that connects to APIs. It's called FF Scraper, and it's for fantasy football, and it connects to, at this time, 4 different API platforms, and basically connects, reads that data back, and then gives it to the user in our data frame. So along the way, every API, pretty much, actually all of them to this point, interact with you by giving you JSON. When you request something, they give you back JSON, and understanding how to parse it is super valuable, because the way the modern web gives you data is JSON. That is the way that any kind of platform or any API or any modern web structure these days will give you JSON as the main way they kind of interoperate with data. All APIs tend to return JSON. Plumber APIs are not different. Sleeper, ESPN, things like that, those are all going to return JSON to you as part of the modern web. I saw, XML came up in the tweet. I actually don't have it. Like, I'm probably comfortable working with XML, but I don't know. I don't know if I'm going to like I don't have enough comfort with like various different sources to go into XML. So today we'll talk about JSON. The first thing I'm going to do is kind of plug Thomas Mock. I kind of learned it kind of simultaneously as he was pushing stuff out, but if you are the type that likes written long form articles about stuff and very comprehensively, Thomas Mock has some great resources. I posted them in the office hours thing, which is somewhere here somewhere, but if not, I'll make sure to include it in my tweets about this later. If he does a great job going through it very comprehensively. Today I'm going to go through kind of parallel examples. I'm not going to look at any code. I'm just going to look at the actual data. Hang on, this is almost illegible. Here we go. I've got links. I made notes about what I wanted to send. So Tom Mock has some great stuff here, which I will dump in our chat. There we go. And there's more stuff there as you know, as necessary. So my plan today is we'll look at kind of the very basic stuff. I see I started writing stuff here and then didn't finish, but we'll start just going through various examples of JSON and what they might look like in the wild, and the goal is to get it to clean data frames. What clean is for a given JSON set or a given data set may vary, and it's more important to understand how you get there and what you're looking at when you see it. Have I looked at Yahoo API? I have barely looked at Yahoo. You're talking about fantasy football specifically, Phil, I'm pretty sure. I have not looked at Yahoo API, primarily because I don't have any leaks there. That's the primary reason. It's also a little older. It's not very well documented, and I think it only works with XML, not JSON. Could be completely wrong, but I haven't looked at it at all, really. Yeah. Okay, so we'll start with marine mammals. If you are not following Jesse on Twitch, you should do so. I will shout people out. There's a whole bunch of people in here that are art streamers. Welcome Afton, O.Nerd, Matty Two Shoes. Our podcast, I think, was here 30 seconds ago. I'm pretty sure. But I'm going to steal Jesse's marine mammal rescue package here. I ghost coded like 3 lines of code at her that worked to wrangle the JSON in question, but we're going to look at it without any of that previous knowledge. So JSON will look like this for the most part, and what we're going to do is we're just going to read this in. So okay. So the very first thing I'm going to say about JSONLite, I love JSONLite. It's the package that I think it's the ubiquitous package for JSON. I don't recommend any of the other JSON ones. They're all either older or not as well supported. Here's the thing. I don't like from JSON. The most common way you'll see it, and I think this is a holdover from previous packages, is you'll see the instruction will be used from JSON. I don't like this for the primary reason that it tries to parse your data for you. So when you do from JSON, it will try to flatten your data, and sometimes this works and sometimes it doesn't, and I usually end up with worse things as a result. In this case, it works pretty well, but my preferred approach is always to use read JSON. And the reason why I like read JSON is because it returns a list, and it's always predictably going to be a list. I don't like getting into unpack or unchop, one of those two, where you have like a data frame column and it's really hard to work with stuff. People will also sometimes suggest flatten. I don't like any of those because I like working with lists and then taking them to tables and then working with list columns. That's going to be my primary approach for almost all the JSON I've ever worked with. It doesn't steer me wrong, but there are other ways. I know about other ways. I've seen other people use other ways to get there. For the most part, for me, I'm always going to take it read JSON into a tibble, into a list with tibble with a list column, and then start unnesting it. So the very first thing with all JSON, once you read it in, is to try to use R's list viewers to look through it. I'm a huge fan of RStudio's list viewer here, and basically to get to it, you go to this environment pane and click on this list, and then you'll see it's an object called X, which contains one thing, which is patience. Patience is a list of 300 with list length 13. So right away, when you start looking at these things, you can see this is probably going to go to a data frame really well. And the reason why I can tell that without even looking at the contents is if it's a sub list of 13, then 13 in a row, so 13 columns, basically you just have lists of 13. So basically, you know, it's going to have the same thing, and you're going to make 13 columns with this data. So, you know, if you see this list of length 13, you want to get there. Is my bed made? Welcome, Greenie. My bed is currently not made, but, you know, I'm also no longer in my bedroom. So, welcome. Okay, so as we explore this data, so you can kind of start looking through and start flipping through the contents of this data. So you got X, you got patience, and then the first element has these 13 columns. They're all currently encoded as character, which is probably the way the JSON was written. So we'll want to do some cleaning there in a second. But if you kind of look through the first two elements, you can kind of see they're the same thing. Sometimes there's sub lists of stuff. The best way to handle it for me is to just keep those as lists. So you know, if there's one thing you take away about Tan's tips on tackling JSON, sorry, can't make JSON, start with a T. You're going to convert this to a tibble, and when you do that, it's going to make a tibble with a list column with the name dot, which is not that helpful, but it's basically now a list column, and as a result, all you need to do is unnest wider, or unnest, unnest wider the first column, and nope, we got a list, we got so what we just did when we did that, and this is kind of how I learned, is if you know that it's 300 long and you want 13 columns wide and you unnest wider and it gives you that, you're doing the wrong thing. So then I'm just going to switch to unnest longer, and now you have a list of 13 elements inside a list column. So basically, if unnest wider doesn't give you what you want, try unnest longer first, and then just, you know, kind of experiment through there. The idea for me is you unnest longer and then you unnest wider here, and it gives you a data frame. That's it. So take it into a tibble and then start unnesting. Unnest auto plug for exploration. Yeah, I don't know if that will work here. Nope. I mean, it gives you the same thing. It does one or the other. So it kind of it does stuff automatically. So basically, to take things to here, we just do that. If you kind of observing this, we notice that the list, so that's like the basic, like if you know nothing else, put in a tibble and then start trying to unnest the columns until you get to where you want. Okay. If we did look at this, so we can see that we want the patience list here. What is the number one inside of unnest longer? Yeah, so great question. I was saying earlier, 30 seconds ago, that you have so when you put it in a tibble, you see this, the column is named dot, which isn't very helpful. And one of my shortcuts to this is take the first column, and so that's what this one is for. It's like this select. When you do a select on a tibble, this is just going to return to you the first column. This is a row name, so that's why it's there, but it's selecting MPG. And so it uses the tidy select semantics and gives you unnest longer on the first column in this case. So it's a tibble of one column, but for me, you know, I don't need to remember that it's named dot. There's approaches to get around this. You know, you can do x equals dot here, and then you can refer to it as x going forward. It gives you the same result. For me, all I remember is put in a tibble, and then I just want the first column most of the time. There. So that's like, if nothing else, the very crude way to get there is to do that. A slightly better approach is, instead of doing like just try unnest, is like level 1 of getting to tidy, and level 2 is to look at this list and say, okay, so I see that there's x and then there's patience. I don't want to just put x into a tibble. I can put patience into a tibble instead. So if I go tibble here, this will skip that first step because I only want the patience part, and I don't want like x and then have to unnest that longer than unnest that wider. So if you go x patience tibble, and then unnest wider here, you get the same data frame. With me so far? So understanding what elements are likely to give you a clean data frame is one of the main reasons why you would flip through this list viewer as you're searching through this data frame and trying to get it to tidy. So you see that it's x, but you don't want x, you want patience. So the idea is to make a data frame for each patient, and then from there unnest this into horizontal table. So basically, as you look through here, you say, okay, so here's a list of stuff. I want it to go horizontally now, unnest wider. That's the logic. Similarly, we had a list here with stuff, and we wanted it to go vertically first and then wider, because that's what happens when you go this way. You go vertically, then wider. You get JSON, so you get to this patience table, and then the goal is to get it to that tidy data frame, right? So in general, you can use patience here. So you can just use x $ patience. That's base our subsetting. Another route to do this that I like a lot is pluck, which does something very similar. You would pluck patience, and then tibble, and then unnest wider 1, gives you the same result. So pluck x pluck patience is going to be roughly equivalent to, I don't know why I printed that whole thing out. It's equivalent. It's exactly the same as x patience. The reasons why I would use pluck instead of x patience is x $ patience is because sometimes you'll want to pick through multiple levels, right? So this may not be a great example because there's only one level. Let me see if there's another one that makes sense. Actually, we'll call it a day here. Call it a day on this one. JSON. Is there a situation where you need a different index for the 2 unnest calls? Yes. In this case, this is kind of like our very introductory level, like dive through it, and it's a very simple table. We will, a good example. So you know what we could do is go to, I haven't looked at Eric's OBS yet, but I did have a participation data. This is Sport Radar. This is NFL participation data. I made a gist of this a little while ago. I want to say like a year ago, 8 months ago. I don't know when I made this. Anyways, I made this JSON list a while ago, and it's a very similar thing where this is an RDS, courtesy of Ben Baldwin. We're not going to tackle actually getting to the Sport Radar API in this part, but I think, if I remember correctly, this returns JSON, I'm pretty sure. Okay, so pretend we just ran read JSON, you get this. And so in this case, you can't just Marshall's question here is about when would you need a different index for the two unnest calls. And this is one of those examples where this is kind of a real data frame that's in the wild that you would use. Thanks for tuning in, Afton. We'll see you definitely later. This is one of those examples in the wild where, actually, let's look through the data. So you've got summary data about this particular thing, and we can unnest various parts of it if we want to. And I did it in this example in one line of code. But we're gonna not look at that unless we have to. And instead, we'll kind of observe what's going on in this data frame. So you've got a set of plays that's a data frame, and we want to get to this data. It has a whole bunch of nested lists, right? So you've got summary, you've got plays, you've got home. This is information about the home team. This is away, which is information about the away team. And inside each, there's a data frame. There's data frames nested everywhere. This is kind of like raw JSON. This is what raw JSON would look like. So, there's definitely multiple approaches to this, where you pluck certain parts of it, and then, you can get who's inside of each thing, who's inside of each play. I think in this question, is in question here. And then from there, you would get, this is an 18-row column, 18-row data frame with 4 columns. You get on Stardew Valley Data Twitter. I think that's just follow Afton on Twitter. I'm pretty sure. But yeah. Okay, so there's a whole bunch of this is kind of what a raw data frame would look like in the wild, where you get a whole bunch of various things. I think, if I remember correctly, and my memory is a little fuzzy on this table, is what we want to do is try to take this to as flat a data frame as possible, and I think I only looked at summary and plays, so I didn't look at any of the home data and the away data. That we'll call that the minimal amount of cheating that we did. So what we're gonna do is pluck. Actually, this is an example where you would use map. Let me think. Call this Sport Radar, actually. Okay, so we want to get to, I think, just the summary and the plays, if I remember correctly. So SR raw, I think it's the case for McGritter extract. Pretty sure. I want plays and summary. So this is another way to subset into stuff. I was looking at for an example for pluck before. Hey, Cedar Prince, welcome. And I think this is the way I want to go with it. So sidebar, because I use McGritter extract here. McGritter provides a wrapper on extract, which is the same as SR raw summary plays, and basically it's just subsetting this list to a list that contains summary and plays. So this, oh, I printed it. These two things are equivalent, so SR and SR2, they do the same thing. So I just like piping things. Whoa. I didn't mean to maximize that. Whoops. Okay. So sidebar McGritter extract is just piping this into the square. So it's also functionally equivalent to, if you're an advanced R nerd, advanced R the book nerd, it's equivalent to doing that as well. But I like McGritter extract. That's how I have it in my mental model. Okay, so we're going to take this into a tibble, hopefully. Nope. So I noticed, so basically what I wanted to happen here was for it to go into 2 columns instead of 2 rows. And I think what I want here, so basically because you want the same data type to be vertical and then different kinds of data to be horizontal, this is an example where just putting it into a straight tibble doesn't directly work. So I think I want as tibble here. No. What did I do? I think I did list. I put it into another list and then put it into a tibble. Pretty sure that's what I did. What that does is it gives me a data frame with the list in it, which I can then start unnesting. Pretty sure. Okay. So now we've got a data frame with summary in one column and plays in the other column. And if you were to just simply unnest this, it would go a little crazy. So we'll start with the summary and start picking through that. Okay, so basically in the summary, we have a bunch of 1 row. Like these basically are all just like a few identifiers about the game that happened. So it's a 2020 regular season game, week 1, and the Falcons were playing against Seattle. So basically we want to try to flatten this into 1 row horizontally, and then keep the plays as a nested tibble, and then from there we can start duplicating each of these rows vertically. So when we finish unnesting and processing summary, we can then unnest plays, and what that will do is it will duplicate the rows going downward for the summary so that the summary table stays the same, and then summary rows stay the same but just get duplicated for every row that is a play. This may not always be what you want, but it's sort of what we're going to go with right now, just to kind of show you working with one summary and then working with plays. So we'll start with summary. We'll unnest wider, I think. Summary, and this is where you can start just specifying by name what you want it to do. So each of the elements that were previously here now become columns. You've got a column with a list about the season, a column with a list about the week, a column with a list about the venue, and a column with a list about home and away. So we can keep unnesting this wider. I think unnest wider only works at 1 column at a time. So yeah, we'll just do them 1 at a time for now. So now we've got the ID about the season. So the thing with IDs, and actually what I'm going to do is start using name sep. And basically what that's going to do is keep the original name. So the original name of the column was season, and it's going to prefix all of the columns that kind of come out of this with the word season, hopefully. Yeah, so the season, and the reason why I did that is because I noticed this column is called ID. IDs are everywhere, especially in something like Sport Radar. So one of the tricks that I like to use to keep it is just to prefix the previous column onto that. And the way I did that was just adding a name separator called season_ID, season_year, season_type, season_name. And we'll do the same thing with week, venue, home, away, and we'll just start with that. I'm going to be lazy, and we'll just duplicate this code. Week, venue, home, away. Okay, so we'll just start flattening this wider. So all the previous season columns are season ID, year, season type, season name. And then you got week ID, week sequence, week title. These all mean something. You know, am I going to do anything with it? No. So let's say that we get all the way through here and we flattened everything except plays. So as we work through this, and we'll probably keep a few things so that we can prove that it kept the data. But I think for ease of us working through it, we're going to start chucking some of these things that we just pulled out. So let's say that we want to keep select season, year, week, sequence. We'll rename this week, name this season. Keep one thing from venue. We'll call it venue name. Home alias. We'll call this home team. Actually, we'll call it home alias. Away alias. And that's good enough. And we'll also keep place. Basically, what we're doing is trying to trim down so because we flattened all of it horizontally, you've got 29 variables now, which is kind of unwieldy to work with. So we're going to just trim down some of that data. You may want some of it for real. You may not. But the idea here is we're just going to try to start pairing out this data. Okay, so we did that. We've got plays. So if you're going to look at it in the viewer. In this case, it works. Sometimes the viewer gets memory heavy, so it may not be as worth it to do this, but we can also click into this plays and start seeing what's in here. So inside of plays, you've got 176 rows, so it should be pretty safe to unnest this. And we can just use the unnest column because we know it's going to give us a data frame when we pick at it. So when you click this and it gives you a data frame already, chances are it's safe to just unnest. And then from there, we can work through some of these home players and who's on the play and who's away. So we'll start working through it now by just unnesting plays. Okay, so that's good. We expected it to give us 176 rows. Notice that it duplicated all of the season, week, like all the stuff we left in, except plays. The plays kind of formed their own thing. I didn't put a name sequence here. I probably should have, because I noticed this ID. So we're going to go back and add names sep equals underscore, just to make sure that we don't get anything confused. Plays ID, plays sequence, plays reference. There's a whole bunch of play-by-play data in this case. I wouldn't recommend going to Sport Radar for play-by-play data when you can get it from NFLFastStar.com already pre-cleaned. But the idea here is you would be able to start, using some of these things. A lot of this info is already duplicated, so you see home.alias, which we kept from the previous thing. But it, you could have just drilled straight to this plays thing in this case, probably, but as a good example of how do you handle one thing and then another. Safe, it won't blow up my computer. I said safe, I mean, was it talking about plays underscore? Or was it talking about memory at that point? I may have, I may have started saying that, but I don't remember exactly what I was referring to. Memory, yeah. Sometimes your computer will, like our studio, will lock up if it's opening a lot of data. So this is only 200 observations, so it's only going to open up 200 rows, and then it doesn't need to open all of these players that are in this play. There's a whole list of stuff inside here that we'll get to if we need to, but the idea here is we don't need when we open this, it won't lock up my computer. Sometimes it will, especially if it's like 100,000 rows or more, or like 1,000,000 rows, and it's nested with a whole bunch of data. It may lock up, like you may like be waiting for RStudio for a while to understand what it's looking at and then start displaying it to you. So it's safe in that you won't end up twiddling your thumbs while you wait for it to think. So I can, generally you'll get a sense of this. You'll definitely run into it, and I think the only way you can learn about what your computer can handle is by like messing it up. It's kind of one of these experimentation things that you kind of have to get to. But yeah, Marshall, yeah, no, I was definitely on the plan. I mean, I put Sport Radar on the examples for a reason. I knew this is kind of one of the more in-depth examples that it had. So okay, so let's shrink this down again. And we'll keep some of this stuff. So we'll keep the same stuff as before. It does. So yeah, R does do threaded read write. The science behind of it, like the programming behind it, usually is abstracted away from the user, so you don't really need to think about it. Usually just be careful about wandering into massive data frames, I think, is kind of the first. It is mostly single threaded, but like a lot of the stuff is written in C to be multi-threaded to handle that stuff for you back end. Also larger than memory file operations, Arrow, Sparklyara. There's a bunch of data packages that plug into dplyr, which is dplyr and tidyr, that work with that kind of data. So you don't need to do it all in memory, but in this case it's all in memory. So trying to just explain what I think about, and locking up my computer is not fun. So when in memory, be careful. That's not what I wanted. What did I want? We're gonna be lazy because I didn't want to rewrite stuff. Okay, so we're gonna start selecting some of the stuff. Plays ID, plays description. Okay, so one of the things I want to do, kind of an example of, is I think that's what I want. Is there anything else I want in this data frame? So I'm just going to keep reducing our example down so we get to an example of map. So with all of these data frames nested, okay. That's what I get for copying. Okay. So inside of plays home players, actually we could just call this home players. Away players. Okay. Wait. Okay. So inside of each of these, we've got a bunch of data frames that contain information about like who was physically on the field at the time of each play. And it could be useful to, so one of the things that is really useful with nested data frames is that you don't have to like unnest it to work with it. In this case, like one of the things that I might want is to get into each of these data frames and collapse the player ID, like to get a like summary of who was physically on the field and what position they played. I think this is a kickoff, which is why there's a mess of people on the field here. But the idea shortly after this, so you'll see who played which positions. You got a center, you've got a fullback, guard, quarterback, running back, tackle, Todd Gurley, RIP, receivers, etc. So basically, what we want to try to do is to get a one column, like a just for each one of these data frames, give me a summary of all the names of the people who are on the field and what positions they played. And we can do this with a map. So like, let's say you were looking at this and you said, okay, so with this, what I wanted to do was, I'll do it in console because it's easier there. What I want to do is just give me a paste of the players here, and basically what I want to do is just give me the names of every player that's in this column. You could also do an average of, I don't know, like you could do like an average of the jersey numbers or something, right? Like there's operations that you want to do with a nested data frame. You don't need to unnest it to work with it. I think is one of the lessons that I think is worth it here. So let's say as numeric, let's say you wanted to get the average jersey number, in case that meant something to you. So the average jersey number is 42.5, which surprisingly close to what I expected, actually. Okay, anyway, so let's do some operations on this data frame, the home players and away players, and we can do that with pers map. So we're going to mutate, and mutate here just means make a new column. We'll call it, give me like player names, call it home player names. I just figure out what I want to do first. Home average jersey. Okay, so is good. So home player names is going to be map. And what we're going to do is pass in this data frame as the argument of our map, right? So we pop that there, and we can just start doing arbitrary stuff with it, right? Like let's say we take, we can always, so when you put home players into a map argument, the first thing can be referred to with .x, and then what we're going to do is pull the name. And pull here just means, we're kind of going back to our example here. Pull is literally just give me the name as a vector. So it's kind of like name. If you do pull, it will give you a vector of names. So you can do pull, or you can do, it's pretty much equivalent to doing that as well. And then what we're going to do is, this is going to give us a list element of 11, because there's 11 players on the field. What we can do is do map, what we can do is then paste these together, and we'll collapse them with the semicolon. And what this is going to do is, it's going to give us, if I did it right, unexpected in mutate. What did I do? Oh, this is unexpected. Do it this way first. Okay. So when you look at this data frame now, you'll get a list of every player that's in that data frame without actually having to unnest it and make your tidy a huge mess, right? So, you know, you paste it together, and you get this, and then there's a null data frame. It handles this by pasting together a bunch of nulls. So even if there aren't players in here, it will still give you a null. It'll still just give you a blank character. So it's kind of nice to work with data frames that are nested. If you have, you know, you want to do the same thing to a bunch of different data frames, one of my favorite ways is to put it in a list and then map over it, so that you can do something very similar to this, but apply a fit function or predict or something like that. Those will all work. So do the same thing, but we'll call it away player names. Again, this should just work. hopefully. Okay, so another thing you might want to do is run an average. Actually, this is probably so you can the type of this column is a list. No, it's a character. It's supposed to be a list. I broke my mental model for a second there. Okay. Anyways, we'll move on. So map. I want to double, so you can specify exactly what kind of column you want by typing map dbl, which is basically just do a map, but then immediately coerce it to a double vector. And it's actually going to return a single double. So a single numeric for each column that you, or each row that you run it on. So let's say we'll map home players again. But this time we run .x jersey number. Jersey number? Jersey. We use the poll this time. I think I personally use poll a little more than just doing the $sign subset. And then we'll make it as numeric because I think it's a character at the moment. And then we'll do mean. Lost the closing bracket. Away players. So that'll give you the same result. No. No applicable method for poll. Okay, so at least, so I think this would have worked without that, and I think it's one of those like distinctions between poll and not poll is it gives you an error message here, where I think Jersey would have just worked. Yeah. I tend to poll for like, I call it like mental best practice, even though it's more just habit. But you know, you get the average jersey number in this case of who was on. So the same people were on both of these plays, which is why the average, I think this was actually just the same people were on for this play. So that's why you get this home average jersey is exactly the same. But you can do math operations with map. I think that's what I wanted to explain about that. The last cool thing that I wanted to show you about this is we'll kind of back up to, actually maybe we'll keep this for a second, and then we'll go to another example, and we'll make sure to hit hoist while we're there. Eric put a OBS JSON thing here, which I think I have to get from here. Oh. So again, read JSON, that's mostly my habit. A tip about GitHub is if you take the link from this, you'll get the HTML. And then if you replace blob with raw, it'll give you the raw data. So if you run that, you'll get, I should restart R so I don't have this being super messy. Okay. So here we get a list of 17 elements, 2.3 megabytes, so there's good amount of data in here. And like I was saying earlier, I've never seen this data, so that's why I went to Sport Radar first, because there's a better, I knew there was a good example for unnesting certain things. In this case, let's look at so what I know about this data is it's Eric's OBS setup and all of the scenes that he has and all the sources that are inside of those scenes. So there's a lot of stuff here. So we can look at these sources. There's a scene order. There's 73 scenes. This is like super overkill OBS setup stuff going on here. So Eric is a someone to aspire to as far as my OBS setup goes. I have a hex sticker as my webcam, and that's the coolest thing about it. Okay, so we will. Okay, let's take some guidance from Eric about what he wants to get to, maybe, because there's a lot of stuff going on here. Obtain all paths to static assets used in the sources, which would be very helpful if we want to change our backend organization or restore after OS reinstallation. So if we kind of flip through, I think these are the static sources, and you got a bunch of IDs, you got settings, and here's the file path. So it would be really helpful, like you could just pluck through this stuff, but it would be actually really useful to make a data frame of what the source, what all of these sources are, and then where you find these files. So I think that's where I'm going to try to get to with this. So okay, so there's a source name. So like just kind of talking out my mental plan before I tackle this is there's a source name, which is random frame image. Hopefully that's not the only name. Slide scene. Okay, so that's just a thing. All right, so you got name here. B is B slide scene. There's a whole bunch of settings about it, which we can flatten into a table, chuck out half of it, and then we'll reuse this code again later. And then inside of this settings object is items, and there's 20 items in this, which is random frame image. So okay, so what I know is we want to get to this file thing, and I think it contains items which contain position, scale, show transition. So there isn't a file for each item that's in here. I think that's the thing I've just taken away from this skim, but we're not going to know until we get there. So actually, I think we can just skip to this sources column, this sources call. So let's start parsing the sources and trying to put it into a data frame. I better save some of this stuff. We'll rename that because it's not the only file I made. Delete. Rename. Okay. Okay. Okay, so yeah, so we're gonna try to get to, so we just looked at this and we said, okay, so OBS raw is a better name. I used to use DFs as all my habits, now I use X, kind of like let X in math, but I try to go back and rename where possible. Then I've already forgotten what I wanted. Sources, I think. So I like pluck for this purpose. You don't have to use pluck if you don't want to, but I tend to use pluck. And there's 175 things. So again, this is a case where we can expect, so there's 20, I noticed, so most of these are 21, but there's a list of 22 here. And I don't immediately know what the difference is, but I'm pretty sure there's a couple that are 22 and most are 21. And so I think it should still mostly work. And we should expect one column to have a bunch of nulls. Okay, so it worked again. You got a data frame now. I don't know which one was missing. I would assume it's filters, probably. This is probably the thing that was missing. Maybe. Not sure. But one of the things that I really like about this approach and about the Tibble and then unnest approach is that it really handles jagged data frames really well. Like, some of these columns had private settings, some of these rows had filters, rows not columns, sorry. Some of these rows had private settings, some of these rows had filters, some of these rows have hotkeys. All of these things show that Eric spends a whole bunch of time on this, and I'm mega impressed at the same time. And you got a whole bunch of different like sources. So I think to get to Eric's goal here, what I think I want to do is only look at the things that have source in the ID, because the scenes won't contain file paths or URLs, which I think is what Eric is trying to get to, like a data frame of all of those things, what they're used. So, you know, we can modify that goal a bit later if we want to, but for now, for the purposes of what we're going to do next, I think that should do it. And we can get there by parsing this ID column where the last few characters end in source. I think that's what I'm going to go for. So we'll leave that as OBS raw because that is still kind of raw. We just slapped it into it. Oh no, we didn't. OBS sources, OBS raw pipe. It's a good thing to always, like, when you start doing like destructive changes to the data, try to keep raw separately, try to keep OBS sources separately. Reasons why you wouldn't do it this way is if OBS raw and OBS sources was particularly heavy in size. Again, mostly working in single-threaded or thinking about R in a single-threaded way and memory management. If having 2 copies of this is expensive, just do it in one pipe and then you can always read back in the raw data later. In this case, data's not too big. We'll just keep going through it here. So let's say we wanted to look at the ones that end in sources. So file sources, path sources, file sources, whatever. We're just gonna roll with that naming. Not gonna think too hard about that. And basically what we're looking at is where ID ends in underscore source. So we'll filter string detect. You actually use string ends here, but I just write it all in string detect most of the time. We'll take ID and we're gonna look for source at the very end. Thanks for tuning in, Samuel. Welcome to the stream. Thank you for the follow earlier, and definitely will be on VODs a bit later. Okay, so we're going to filter where the string, you just check the word source at the end of the ID. So that gives you 88 different types of sources, some of which are images, some of which are VLC, some of which are colors, FFmpeg. I think these are animation. These are videos. There's images. There's text. There's more text. Lol. Hey, our studio has dark mode. What do you mean you have failed me for not turning up to my Twitch before. That is the failure here. I'm kidding, of course. Yes, our studio has dark mode. I recommend RS Themes 1 Dark. If you go down to the bottom, you'll get a link to it and kind of talk about what themes I use. Okay, so you got this, you got the name. There's a bunch of settings here, which I want to look at. I think this is where most of the contents I want will be. So we'll parse out some of this stuff because it's not all necessary. So let's look at like enabled ID, name, and settings. I think that's all we want. So select ID, name, enabled, settings. Also welcome Rogers, welcome Zach. That's Zach, right? Yeah. Welcome to the stream. We are working on JSON, if you hadn't already noticed. Okay, so we've got stuff here, and what I want to do is, this is a good example where I want to use hoist because I don't want to just spit all of this stuff out. But we want to try to pick out as much stuff as we can, and I think what we want is Oh, Eric, you'll probably want to sanitize this a bit later, by the way. I think some of these things shouldn't be public, but I will kind of continue blindly here and we'll deal with it a bit later. Okay, so we'll hoist the settings. So hoist is unnest wider, except just some of the stuff, not everything. So the URLs, Eric, by the way, I think you'll probably want to be careful about. We'll look at it very briefly here, but I think the URLs, like the local files, I don't think matter, but some of these URLs have IDs and stuff in them. So I will, in this case, I think I will pull. Okay, so let's continue with this for a second. So you've got a bunch of local files. So there's a bunch of local files, there's looping, there's closed when active, so there's a whole bunch of attributes, but all we care about for the purposes of what we want to get to is what this local file is. So we want to pull that, and the same thing with these images. We want to pull the file that the image is. You want to pull the text. So these are file sources still. I think these are file sources. This is text. So these are text that's in a file, in its file. So there's a text file, there's a local file, there's file, there's I think these are just straight text. Nope, these are also files. Okay, these are mostly files. So we'll try to pull all the various file paths except the URLs because I think those are private. So from settings, we're gonna hoist stuff. If you're thinking about this, whenever I use hoist, I think of, dost thou even hoist from the do you even lift bro meme. It's one of my favorite memes. So hoist is pluck just the one column that you want, and if that column doesn't exist, make a column with NA in it, which is super useful in cases like this OBS file sources, because we don't want everything. So we want file equals file, and you can specify so the first argument is what you want it to be called in your new data frame, and then the second argument is what is it called inside of each either sublist or data frame. So in this case we'll call it file, and then we'll call local file equals local file. I've already forgotten what else it was, so back to this viewer because I've already forgotten. There's local file. Skip the browser sources. We'll skip to there's text here. So we'll pick out text. Did file already, did local file, did text, and I think this is called something different again, but I forgot what it was. Text file. You don't have to name them exactly the same. You can call this file 2. It's this one has to correspond with the data frame, and then this one corresponds with what you want it to be called in your top level data frame. And so when you run this, you can expect the contents. Hoist will pull out of the settings, and it will by default remove that entry from settings. So in this case, it used to have a thing called file. Settings no longer has a file. You can change this behavior with an argument that I'd never use called remove. But most of the time I don't use it, and then immediately after this, most of the time what I end up doing is just doing select settings, because I've only picked out the stuff that I want. So it's a common pattern that I like to use when I'm picking through settings. You don't have to do this if you don't want to, but for me that's where I want to get to. And that is hoisting. And so basically you've picked out all of the various files. We call this file 2, but doesn't really matter. We'll call it file text here, so that I know what I'm looking at. And so basically now you've got a bunch of file paths. In this case, it's home, Eric, media drive, Shiny Death Series media, trailers for streaming, Vry's trailer, Barkermeyer, my paintings.txt. And then what I think is useful here is none of these overlap. So one of the things we can do is collapse all of the file, local file, and file text things together in a mutate here. We'll call it mutate file equals coalesce. And this will take the first non-NA in that row. So file, local file, file text. I think text should stay on its own because it's not a file path. So we'll do that, and then we'll set the other stuff to null. And that's basically the same as selecting. The like dropping each column. Sorry. Okay, so, and we'll also set the settings to null in the same way that we wanted to drop it earlier. We'll also drop the settings by running equals null. I use this pattern when I'm already writing mutate. Coalesce is SQL. Exactly. It's exactly the same behavior. If you're already familiar with SQL's coalesce, does the same thing. But are like. I don't know if it's exactly the same thing, but it's very close. Okay, so now we've got this file. We've got ID. You've got the name, you've got whether it's enabled. I think they're all enabled at this moment, but you know, if you're going to use it, it's already cast to logical, so that's in case you want to do something with that. You've got the file where it lives on Eric's computer here, and you've got the text that goes into this local source if you know, Eric wrote it from scratch or something. Some of these don't have anything, so it may be worthwhile. Oh, browser sources don't have that, I think, globally, and that's because I explicitly didn't want to pull out the URLs that I saw in that. What package is it for R? dplyr. dplyr coalesce. Dplyr coalesce. AKA, it's already in your main workflow. It's exactly the same. Yeah, I think that's very close to where I wanted to get to this. Any questions about all that so far? I've kind of blown through it all. But I will aim to stick with. Try to ride this out for a little bit longer. I think somebody is streaming after me, so we will try to raid somebody who does data science today. I think that's Alyssa. Hoist versus Pluck. Yeah, Pluck is for lists. Hoist is for list columns. Hoist also gives you multiple. Hoist will also give you multiple columns. Pluck, I think, only works on one thing. So Pluck is like, take just this one thing, this one element out. Whereas Hoist will take this element and this element and this element and this element, and if they're nested, they will also pull out. It'll pull out as a list. So if we are looking at this earlier, let's say we're looking at the OBS sources here. There's 175 observations of 175. There's 175 lists here. If I only wanted to look at sources, I could, or no. If I only wanted to look at, so you can still use the, sorry, so before I continue here, you can use the same one syntax to take the first column because it's still named the dot from my piped in Tibble. You can hoist just the stuff you need. In this case, you need ID, name, enabled, settings, and hoist will pull out just those ones and will leave this dot column at the very end with stuff that wasn't looked at, i.e. this. So it's a very efficient way to pick out specific things from those list columns. And then from there, the rest of this code should still work. We'll verify it by doing that. And it does the same thing, and goes from there. So this code will still run top to bottom. You can use hoist here instead of on nest. Actually, I'll leave it that way because I think that's slightly better. And yeah. Eric had another question here about how many... Hang on, I had an issue come in, so I should look at that and see how long I think that might take. And then, somebody dumped it in here. Here's a recipe database. The instruction stuff is in JSON, and I had a really hard time working with it in SQL. Okay, so you got food.com recipes, and you want to get it into a tidy... These are all CSVs, though. The instructions and stuff is in JSON or similar. There's tags here, there's recipe steps. Okay, this could be interesting. Kind of just wrapping up my thought about this OBS high-level summary statistics of the number of sources used in each scene. You could... there's probably a right path to do it. Highlighting some thoughts on this, so... I think this is only one scene. This gives you the list of all the scenes. I think these sources are... I don't know if they say what scenes they're used in. This may not be the right JSON output to do that. Yeah, I'm not sure that this is the right JSON to answer that question. Just because I'm looking at all these settings, I'm looking at what's in each source. I don't think this is I don't think this tells you which source is used in which scene. I may be wrong. It may be in a different part that I'm not looking at. I see a bunch of transitions, sources. Yeah, so I don't think I see which scene uses which source. So in that case, I don't think it's possible to answer the question that Eric asked here. I'm the Monday Night Rockstar? I don't know, like... I mean, I could stream regularly on Mondays, but, like, it's also, like, football night, so it would have to be, like, I would be super distracted otherwise. So if I were to keep doing this, it would be, like, 6 to 8 on Mondays Eastern Time. And I don't know if I want to, like... I'm not sure about the timing yet, but I'm kind of keeping it open for now. Anyway, so, yeah, so Eric, sorry, before I wrap this question up, yeah, I don't think that's possible at the moment. I may be wrong, but I think that's sort of how I would look at that. Okay, so we'll call this JSON OBS. Put JSON line, even though I don't think this is JSON. I'm pretty sure this is not JSON. Anyway, so sorry, back to Tony's question because I got distracted again. I don't plan to have a Monday night session, and I kind of like these tutorials to be grouped around a topic rather than just open office hours, bring me whatever. So I'm happy to go over the same content or similar content again. But yeah, I would, I'm happy to stream another, like, tutorial-ish session. I just like them being, like, aggregated around one topic where I kind of share as much as I know about it, rather than just being, you know, hanging out on R4DS Slack and answering questions, which I do anyway sometimes, but I don't think that's as interesting. Okay, so this looks interesting. I think Maddie Two Shoes brought this in. Pretty sure he was trying to work with it in SQL. So, we'll try to hit this. I think it's either the pre-processed or the... Okay, so I'm not sure what format this is in, but let's 851. Bring in the raw recipes. Nope. Okay, I can't do that. How do I download you? Invalid Firestore path. Okay. How fast is Tan's internet while streaming at the exact same time? Actually, not bad. Alright, I'll take it. We're going. Okay. We only want... I think we have to extract it all, though. Extract all of this stuff. Yeah, so if you're updating with new URLs, it's just the browser ones. I don't know if you can regenerate those tokens or just take it down. I don't think anyone's looked at it or whatever, but it's worthwhile not to have people stealing your keys or broadcasting your music or doing fun other things. Okay. Yeah, you'll figure it out. Yeah, no worries. Okay, so paste all that there. I don't think I want to deal with the interactions. We're not actually doing data science here. We're doing data wrangling here for the moment. And I think he just wanted to look at the recipes. So we'll look at the raw recipes. If it's too much, we'll look at the other one. Read CSV. Restart first, then rerun. Okay, we have stuff. We've got 6 character columns, 5 double columns, that's numbers, and 1 date. We got 231 observations with stuff in it. Let's look at it. I was worried about lockup earlier. 261, like if it's not super complex, will still open. I once made the mistake of trying to open sequential stuff and it didn't open. Okay, so this looks like a delimited format with square brackets, so it must be, I feel like it's a Pythonic list in here somewhere. So my first inclination is, okay, so this is a CSV, so it's not exactly JSON, but it would still make a bunch of lists, I think. This nutrition, I don't know what it is. Whoa. Don't know if there's much more. Map of ingredient IDs to ingredient names. Okay, yeah, we're not going to be able to look at that. Okay, so how would I take this to a actual R, like nested R data frame, and then start unnesting them? So the first thing is, these square brackets are not R, so I could string split on comma still. There's a whole bunch of text in these descriptions. Okay, yeah, so we'll kind of do a brief strategy here. My strategy is going to be map. This could be an interesting way to use across. When you use the string split function, it returns a vector with the split data. So what I want to do is split on the... So I'm going to clean it by getting rid of all the square brackets. So either of the square brackets I'm going to get rid of, and then I'm going to split this data on the comma. Cross our fingers that there's no commas in the tags. Actually, that should work on most things except... Right. To convert these files into the pickle format required to run our code off the shelf, you may use pandas read to pickle. Okay, so this is like somebody making an RDS, like flattening an RDS file or something, because I think these were originally nested vectors or something. In this case, we'll just kind of have at it. This is more of a data cleaning thing than a this is more of a data cleaning thing than a real JSON, but I think it will kind of talk through the same examples of mapping and nesting and stuff. Okay, so let's say the things that we want to unnest are... I say unnest. We'll say tags, nutrition, steps, ingredients. Those are the things that we can unnest. I'm just reading from this list here and guessing at what will need to be converted into a character vector. Tokenized, same thing, similar thing. So mutate across C. Bing. I want to string R, string remove all. So I'm piping .x. .x still refers to each column. So this is kind of like a per-like notation for it. We're going to remove all of the square brackets. So we're going to escape the escape character. That's an R thing. And then we're going to escape this square bracket, which normally means something in regex. But we're going to tell regex we don't care about that. We just want the square bracket itself. And then the other square bracket. And then we're going to string split on comma. Blindly wander into it, map over it. It is thinking. I have no idea how long that's going to take. If it takes a while, we will condense our example, but let's let it work for a minute or two. Hey, we did stuff. Okay, so alright, so it looks like that basically made a bunch of nested. So this is functionally nested, but it's not a nested tibble, it's just nested character vectors. And this vector has each of the steps in it. So we can unnest it. But I think first I also want to remove, I think Python uses single quotes here, which I don't think is necessary. So we're going to also remove the single quote. And then we will leave that for a second. We'll rerun that. It took a minute, so we'll wait. Should take a similar amount of time. Okay. So again, kind of looking at this, we've got recipes, you've got a bunch of tags, you've got a bunch of nutrition facts, you've got a bunch of steps, and ingredients. These won't make data frames. So, you know, one of the things that you should do here, understand here, is that this is not meant to be transmitted into a data frame. It's kind of somebody's recipe that's been kind of string parsed. So this is probably what I think this is what the pickle does. So this is what the pickle's meant to be, is that it's just a bunch of tokenized. So tokenized here meaning it's a vector inside these, which you can kind of unnest. As you can still unnest them, it's just it's not meant to make a massive data frame the way Sport Radar did. So one of the things we can do here, like it doesn't have list attributes. I think it's just a vector. So in terms of unnesting, things that we can do here is understand how many recipes have certain tags, and we can do a count of the tags and count of recipes by tag. And to do that, we could do like tags, recipes, we'll select name, ID, minutes, name, ID, tags, and then unnest the tags. And that'll give you when it finishes thinking, 4.1 million observations of 3 variables, which we can count. We can count the number of rows by tags. So tags. And if you count them, you'll understand that in this recipe there are 572 different tags. Some of them have none, and others have so preparation, there's 230 of them are tagged with preparation, 213,000 are tagged with course, time to make, main ingredient. There's some of these tags don't mean anything, but some of them like are 60 minutes or less. There's a number of servings tag. Then you can kind of study what the tags are for each recipe or something. Or if you wanted to do the same thing but with ingredients, you can do the same thing. Ingredients, I think. One of my favorite ways, I like this string function instead of the glimpse function. Because I like that I can specify the max number of levels. So in this case, I'm looking to see what the names of these columns are and what's roughly inside of them. And I think I want ingredients. Yeah. So let's say we wanted to do the same thing, but by ingredient. We can do ingredients here. And then you get a count of ingredients. Same effect. There's more cleaning that you can do. So there's a space here that's in front of each of these, and there's a quotation marks. That's probably because this was meant to be pickle and not it's not JSON. It's not meant to be written, like it's not R. There may be better ways to convert pickles to R that I'm not familiar with because I don't use Python on a daily, but it could be, this could be a useful way to get to it if it is hard written out in CSV. Anyways, salt is used a lot, and so is butter. This surprises literally nobody. Yeah. Anyways, that is that example. It is 8:30. don't know if there's something else that I wanted to look at. I have a whole bunch of code that works on Sleeper API, MFL API, ESPN API, etc. But honestly, I think I've shown everything that I was going to cover. So I talked about read and parse JSON. So parse JSON is the same as read JSON, except it doesn't refer to a file. So if you have like a character vector that is JSON, you can then parse it. So you pass in a character vector, like an object, into parse JSON, whereas you pass read JSON a file path. That's the only difference between these two. I didn't get to finishing everything that I wanted to, but I think I mentioned in my tweet talking about on nests and hoists, which we looked at both of those examples already. Dplyr. So basically, I was talking about on nest and hoist, which I think is the main part of working with JSON. Once you run the actual read JSON part, we looked Dplyr. Dplyr is used everywhere. It's kind of like breathing in R for me. Same with, we talked about different ways to work with nested tibbles in Purr, especially with the Sport Radar chunk. So that was kind of a useful chunk for explaining stuff. We talked about a lot of the hoist stuff in Eric's OBS tutorial. Yeah, I think that covered all the content that I wanted to cover. We don't have to go through anything further, but if you have questions, I'm happy to take them now. Otherwise, we can go raid one of the data. Show us a reduce too. We could do a reduce, yeah. Would you like a reduce? We could do it accumulate. Actually, I've forgotten reduce already. Apologies. It's been over a year, okay? This was super cool. Thanks to you. Yeah, no problem. I'll commit all of this code. I probably won't pre-process. I won't redo the stuff. Reduce. Tony, you could just run bind rows on that. You don't need to reduce that. Bind rows will handle your list of data frames. You don't need it. But yes. Yeah, I mean, I'm glad to help. Feel free to ask me more questions. I'm open to redoing another tutorial like this with different contents, but I tend to try to keep them sticky. So I did a scraping one recently. I did this recently. I talked about debugging Shiny, so that might be another thing that comes up in things that I talk about. But for now, this will be all here. It'll be on VODs. If you want to watch it again or rewatch stuff, feel free to ping me on Twitter or in a comment or something. I'm also part of the R4DS community, which I will plug here. So feel free to join that community. That's where I met a whole bunch of people like Tony, and we now share our memes all the time. Very worth it. Very good place to hang out and get our help. I'm also part of the NFLverse Discord. If you're here because of me and NFL, you probably already knew about that. But yeah, check me out on Twitter, give me a follow, blah, 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 blah. And we'll go raid, who's on? So we got Nick, you got Alyssa, Trevin also. Any preferences? I'm guessing Alyssa will be doing something Tidyverse related. It's probably the closest. Tidy Tuesday related, sorry. But we raided her last time, so we could raid Trevin. I'm less familiar with what he does on the regular. Or we can raid Nick, who will also talk about other things. Sliced-ish stuff, probably? Not sure what he's doing. Nick is moving a couch. Okay. Okay, Nick is moving a couch. We could go hang out with Nick. Or we can go do code. I think this is a code stream, so we'll try to go do code. That's probably where we'll go. But thanks for coming in, everybody. Let me know, give me feedback. Generally, I probably won't make it much more formal or make slides or do much more prep than I did today. But this will be kind of the vein of things that I'll be doing in the near future. So if you're keen on more content, let me know what kind of topics you think I could tackle well. Or if you want another rerun with different examples of stuff, let me know. And we're gonna go raid Alyssa. Okay. Feel free to stick around, and we'll get more R data content very shortly. Take care.